Now we are going to solve problem number 4 here from this exam, this calculus exam, which consists in calculating this indefinite integral here. So we just have to calculate the indefinite integral. And let's do it. Let's do it here. So I will write the integral of 1 over, we have x plus 1 squared. Then here we have the square root of x squared plus 2x plus 2, like this, dx. And now I'm going to rewrite the square root in a different manner. This is equal to integral dx divided by x plus 1 squared, and then I have the square root of x plus 1 squared plus 1. So I can also rewrite the integral in this form. And now I will make a substitution. So I have reasoned on this integral a few minutes before doing it during the exam, while I was helping the students. So you might check the first problem, and you have to go back a few videos to understand, let's say, the background for this exam. I have helped a student solve the problems, and I was doing it live. So she sent me the pictures, and I would solve the problems, and after I solved the problems I sent back the pictures. So this is not something, as I said, that I recommend, but this student had some difficulty in passing the exam, so basically I did my best to help her. That's what's up. But anyway, let's get back here. I reasoned on some simple substitution which could simplify the calculation, and I found that t equal to minus 1 over x plus 1 could be a good substitution. So we can calculate dt, which is equal to dx over x plus 1 squared. And from here you can also see that 1 over t squared is equal to x plus 1 squared, like this. And this integral can be rewritten in this fashion. So this is the integral dt divided by the square root of 1 plus t squared over t squared, which you can rewrite as integral of the absolute value of t dt divided by the square root of 1 plus t squared. And you can rewrite this as plus or minus, because you have an absolute value here. Then we will try to get rid of this plus or minus, but just wait a moment. First rewrite it as plus or minus, and then here you can put t inside the differential, so you can rewrite this as dt squared, and you also have to multiply by 1/2, because 1/2, the differential of t squared, is simply equal to t dt, and the absolute value is contained here in this plus or minus, which we'll have to take care of, but in a few steps. And then we divide by the square root of 1 plus t squared. Now this becomes a simple integral to calculate. So this will be equal to plus or minus the square root of 1 plus t squared. So if you take the derivative of this function with respect to t squared, so in this case the variable is t squared, well, you will get 1/2 times 1 over the square root here. And you also have to add a constant, plus a constant, but I'm not going to write the constant. And if you go back to x, you get plus or minus, and then here you get the square root of 1 plus 1 over x plus 1 squared. And this plus is something which is associated to the sign of x plus 1. So you get a plus if x plus 1 is less than 0, and you get a minus if x plus 1 is greater than 0. This is basically related to t, because if t is positive, then it means that x plus 1 is negative, and vice versa. If t is negative, x plus 1 is positive. You can simply see that from the substitution that we have made. This substitution here. So from the sine of t, you can also calculate, you can also, let's say, see the sine of x plus 1 from this equation here. So there is no strange thing about that. And then you can rewrite this as plus or minus square root of x squared plus 2x plus 2, and then you divide by x plus 1 squared, which is equal to, now let's rewrite this plus or minus by using the signum function. So this will be minus signum, which I'll rewrite as SGN. So this is the function which simply gives you the sign, and by sign I do not mean the trigonometric function, but I mean this, the sign of a function. So we must get a negative sign if x plus 1 is negative. So if I consider the signum function of x plus 1, if the signum function is positive, then we must put a minus sign, because if x plus 1 is negative, then we must get a plus. So that's why I have a minus here, because if x plus 1 is positive, the signum function is equal to 1. So we must put a minus here. And then here I will have the square root of x squared plus 2x plus 2 divided by absolute value of x plus 1. But now you can also rewrite the signum function simply by using its definition. So signum of x plus 1 is equal to the function itself, which is x plus 1, divided by the absolute value of the function itself. So absolute value of x plus 1. This is the signum of x plus 1 by definition. And then here you have the square root of x squared plus 2x plus 2 divided by absolute value of x plus 1. But now you can easily see that you get minus x plus 1, and then we divide by the square of the absolute value of x plus 1. But if we take the square, we can also remove the absolute value. We have x plus 1 squared, right? So we just simply take the square without the absolute value. And then here we have the square root of x squared plus 2x plus 2. We can cancel this with this, and therefore the result will be minus the square root of x squared plus 2x plus 2. And then we divide by x plus 1 without any absolute value at all. And if you want, you can add a constant, an additive constant here in the result to be more general. And this is the result of the calculation.